We'll start number 6 by finding the zeros. Basically what you're going to do is you're going to do your t-chart. So our first 0 will be x equals 0. Our second 0 will be x equals 2, squeezing that in. And so will our third 0. So remember, we don't need to write those twice because they do have the same value. And then we have x equals 5. So I'm going to go over to my graph, and I'm going to put a 0 at 0, 1 at 2, and 5, I'm going to squeeze it in all the way out there. There's 5. All right, now remember what we're going to do is we're going to do a sign chart. I'm going to put the sign chart over here. And on that sign chart will be your zeros. So we have 5, we have 2, and we have 0. So remember what we're going to do now is we're going to go back to that original function in factored form, which was x minus 2, x minus 2, and x minus 5. And we're going to plug in values. So I'm going to look at my sign chart, and I'm going to pick a number between 0 and 2. So obviously I am going to pick 1. So I'm going to put in a 1 everywhere I see an x. Now when I put in a 1 into x minus 2, I'm going to get a negative 1. Obviously the same thing here. And then if I put in a 1 in the x minus 5, I'll get negative 4. Now if I look at that, I have an odd number of negatives. So a negative times a negative times a negative would be a negative number. So when I go down to my sign chart, I know that I will have a minus between 0 and 2. The function will be negative, meaning it will be below the x-axis. Let's go back and let's pick a number between 2 and 5 now. So let's say 3. And keep in mind that I'm plugging that in right here into the original function. So I'm going to get 3 times, now when I plug in a 3 into x minus 2, I'll get 1. Same thing with the third term. And then when I plug in 3 into 3 minus 5, I will get a negative 2. Now, there I have all positives except for the last term. So a positive times a negative will be a negative. So interestingly enough, our sign chart shows that the function is always negative, which means that the function is always going to be below the x-axis. So the way that we're going to show this is we are going to start at the first 0, which is at 0. We're going to be below the x-axis. Now it does need to come up and hit 2, which it will, but then I'm going to stay below the x-axis. And that is what your function f of x will look like. Number 7 simply wants the first term and the last term. So all I'm going to do is I'm going to take my first term, which is my x. I'm going to raise that to the 4th power, and that will give me my first term, which is x to the 4th. Okay? To find your last term, you're going to take the last term in the parentheses, which would be negative 3y, and I'm going to raise that to the 4th power as well. Now be careful because the negative 3 is getting raised to the 4th power, and so is the y. So negative 3, when I raise that to the 4th power, is 81, and then y to the 4th, and that will be your last term. I'm going to start by doing the quadratic formula first. So I'm going to start by getting your equation into standard form. So I'm going to do 4x squared minus 10x plus 1 equals 0. So then I have x equals negative b, which is 10, plus or minus the square root of b squared, which is 100, minus 4 times 4 times 1. Squeeze that in. And the whole thing is over 2 times a. Since a is 4, that's going to be an 8. right, so we just keep going and we simplify. 10 plus or minus. Now that square root is going to be 100 minus 16, which would be the square root of 84. Now I'm going to break 84 down, and that breaks down to 4 times 21. And that whole thing will be over 8. Now we know that the square root of 4 is a 2, so we can then look at that and break that down a little bit further. Oops. So I have x equals 10 plus or minus 2 times the square root of 21, that whole thing over 8. Okay, now again we see that 10, 2, and 8 all have a common factor, so let's pull out a factor of 2. So this will be a 5, a 1, and a 4. So now let's split up our answers, and we get x equals 5 plus radical 21, that whole thing over 4. And lastly, I'm going to try to squeeze this in. We're going to get 5 minus, oops, I'm going to squeeze it in over here, square root of 21, that whole thing over 4. And those are your two solutions. They were also asking you to complete the square. So when we complete the square, remember that we want to get that lead coefficient to be 1. So I'm going to divide everything here by 4. And that will give me x squared minus 5 halves x. I'm going to leave a space, and that will equal negative 1/4. And again, I'm going to leave that space. All right, so what I'm looking for is I want to have half of this middle term here, which will end up being 5/4, and then I need to square that 5/4. So I square the top, which will give me 25, and I square the bottom, which will give, excuse me, which will give me 16. So I have a plus 25 over 16 over here, and I have plus 25 over 16 here. Okay, now on the left here, I'm going to try to square that. So remember, the little cheater method is just to take the sign of the middle term, which would be negative, and take the square root of what's in the box, which is going to be 5 over 4. And it will be that quantity squared equals. And then we're going to add 25 over 16 with negative 1/4, and I will get 21 over 16. All right, I'm trying to get x by itself, so I'm going to take the square root of the left, and I'm going to take the plus or minus square root of the right. And I end up with x minus 5/4 equals plus or minus. Now, I don't know what the square root of 21 is. It's not a perfect square itself, and there's no perfect square in it, so I'm just going to leave it. However, the square root of 16 is a 4, so I'm going to break that down. So then I get x equals 5/4, because I'm going to bring that 5/4 over to the right-hand side, and when I do that, I change the sign, plus or minus the square root of 21 over 4. And lastly, I'm just going to break that up. So I have 5/4 plus radical 21 over 4. And once again, I'm going to squeeze this last one in here, and I have 5/4 minus the square root of 21 over 4. And those are your two solutions, and you see that they match what we have over here. Number 9 is asking us to solve, so I'm simply going to factor by doing the basic little a m. So what adds to negative 20 and multiplies to 64? So that would be 4 and 16. Now I need for it to add to negative 20, so both those signs are going to be negative, and I need for it to multiply to positive 64, which it does. Now, since my lead coefficient is a 1, I can again just do the AM, and if we look at this has a degree 4, so when I go ahead and I open up my two sets of parentheses, just make sure that inside your first set and inside your second set you're going to have an x squared. So we're going to do minus 4 and minus 16. Now both of those are the difference of two perfect squares, so let's keep going with those. So that's an x plus 2, x minus 2. And the next one is x plus 4, x minus 4. Since they want us to solve, we're going to do our little t-chart here. And we're going to set each of those factors equal to 0. So we're going to get x equals -2, x equals +2, x equals -4, and x equals +4. And those are your 4 solutions. Part A is asking for the zeros of the function, so we're going to look at the graph and we're going to see essentially where it hits the x-axis. Now the x-axis, if you read the directions, represents r, which is the radius, and they want you to estimate your values to the nearest half unit. So if I'm reading from left to right, for part A, my first 0 is going to be at r equals -8.5. My second one is going to be at r equals 0, and my third one is going to be at r equals +8.5. Part B wants the maximum and the minimum values. Now, values mean that they want to know the y values, how high something is. In this case, our y-axis is representing the volume, and they do ask us to, represent it to the nearest 50 units on the vertical axis. So my maximum is my highest point, and if you look at my highest point, that maximum value would be a volume of 800. Then they want a minimum, again, a value, so that volume would be at -800. So your answers for part B, your maximum would be at 800, and your minimum would be at -800. Part C wants you to take the equation V of R, and it wants you to find the actual value of C given the rest of this equation. Now we're definitely going to need our calculator here. Now if you notice, if you look at everything else in this equation, so we're trying to find out what C is. So we have a V of R. Now remember, that's just a fancy way of saying Y. And we have R's, which is a fancy way of saying X. So we're looking for a point on the graph. So what I chose was, I chose the point 5, 800. So that's my maximum, and that was the point that I decided to put in. So 800 is my y value, so I'm going to plug that in here. I don't know what C is, that's what I'm trying to find out. So I'm going to put in 5 cubed minus 72.25. That value is going to be multiplied by 5. And then I'm just going to take my handy-dandy little calculator here, and I'm going to work that all out. So I'm going to get 125 here, minus, and then when I multiply 72.25 times 5, I get 361.25. I'm going to subtract those two, and I will get 800 equals C times, and that ends up being -236.25. I want to get the C by itself, so I'm going to divide both sides by -236.25. -236.25 over here, and these will cancel out. And we're just going to divide that out, and I will get a C value of -3.3862. And that's what they wanted for part C. Okay? All right. So now, look at part D. Part D says to use the graph to estimate the volume that has a radius, a volume of the cylinder when the radius is 2. Go back and look at the picture, okay? Find when R is equal to 2, so go to your x-axis, go out 2 units to the right, and follow straight up. And I'm looking at that roughly for part D. My pen is not wanting to work today. I would tend to say that I'm going to go with roughly 450. That's how high I think it seems to be. Now, for part E, what they want you to do is use the formula. Now, that's the formula from part C. And they want you to actually find the real value. So remember what part C said. It says V of R. Remember, that's a fancy way of saying Y. Now, we know what our C is. So now we know I'm going to go to my answer from part C. And I know that my C was negative 3.3862. And I'm going to multiply that by, and then it says R cubed. Now, they're telling you in part E that the R is 2. So I'm going to just replace that with 2 cubed minus 72.25. And that is going to be multiplied by R, which again, they're telling us is 2. All right, so I am just going to drop down the V of R, which again, fancy way of saying Y equals. And I'm going to keep this negative 3.3862. And I'm going to just take everything inside these parentheses and I'm going to simplify. So 2 to the third, I'm just going to throw that right up here just so you can see it. We know that that's 8 minus, and then 72.25 times that 2 is 144. And that would be 0.5. Okay, so 144.5. So when I do 8 minus 144.5, I get negative 136.5. I'm going to multiply those two numbers out, and I get 462.2163. Now, so if you look at that, from part D, I said it was 450. Part E, it's actually 462.2163. So it says, how close is the value from the formula to the value on the graph? You could subtract the two and see what the difference is, but we're pretty close. And there is our answer to part E.